All right, I'm going to call this guy M1. I'm going to call this guy M2. I'm going to call this guy M3. Okay. In the previous video, I showed that the acceleration of this system is M3G minus mu M1G. That is the weight of this minus the friction of that, right? Divided by all of the inertia, right? So M1 plus, and then the pulley was 1/2 M2 plus M3. I will show you how to do that without using like clockwise torque, anti-clockwise torque, systems of equations. Okay. All I'm going to do is I'm going to pretend like this falls some height h, right? And we're going to figure out the velocity at the end of falling h, right? And then what I can do is I can use suvat, right? Remember, v squared is u squared plus 2as. If it starts at 0 and it falls a distance of h, then v squared is just 2ah, right? So then a is just simply v squared over 2h, okay? This is the magic. So what I'm going to do is I'll set up an energy equation, solve it for v squared, take that expression, divide by 2h, and I must have a, right? And you don't have to have a height. You don't even need to know the height. The height actually cancels out. I'll show you this, okay? So without using systems of equations and substitutions and clockwise torque, right? I hope I'm selling this. All right, I can come to this equation. I'll show you. All right, so this thing, basically all that's happening here, our only asset is that this guy has potential energy, right? So on the left side of our equation, we've got M3 GH, right? Now when it's fallen a distance h, this box will have kinetic energy. This guy will be rotating. This will have kinetic energy, and then it also will have done work against friction, right? So we can't forget that, right? So our energy, the potential energy, is going to turn into kinetic, and then work against friction, right? Somehow friction's got to go in there, right? So let's just go 1/2 m1v squared, right, plus 1/2 I omega squared of this guy, right? We haven't even substituted yet, so we don't have the m2 in there, right? Plus 1/2 m3v squared, right? And then we've got to do work against friction, right? So plus mu times m1 times g, that's our force, right? And then the distance it travels will be h, right? If this moves down h, that will move over h, yeah? All right. So, and that's a little bit of physics, right? I guess you have to know this has kinetic energy. And then in the last picture, picture everything, right? This guy's moving, right? M1's moving. The pulley is rotating. The falling mass is moving. Don't forget the falling mass, right? And then this, this might be the thing you forget, right? Is that we had to do work against that. Okay. But really, other than that, we were okay, right? We'll figure this out. Okay, so now what we want to do, I guess let's substitute for this guy. So let's go M3 GH, and then I'm going to subtract that guy. I'm going to go minus mu M1 GH equals 1/2. And the reason I did that is I want all the v squared terms on this side, and that's what's going to happen. M1 v squared plus, and then it's going to be 1/2, and then it's a pulley. Let's say it's a cylinder, right? So 1/2 mr squared times v squared over r squared, right? Plus 1/2. All right, and then obviously the same thing happens, right? We end up with m3gh minus mu m1gh is 1/2 m1v squared plus 1/4. Oh, that was m2 plus 1/2. Okay. And then the next thing to do is factor out the v's, right? v squared outside of 1/2 m1 plus 1/4 m2 plus 1/2. All right, and then drum roll, please. V squared equals m3gh minus mu m1 gh over 1/2 m1 plus 1/4 m2 plus 1/2 m3. And then if I want to make that into acceleration, all I have to do is take a v squared divided by 2h, and I've got a, right? So let's divide it by 2h. And then let's put a 2h down here, right? Now watch what happens. This becomes v squared over 2h is a, right? So the left side becomes a, and then get rid of the h, right? And then multiply this by 2. So we get a is equal to m3 minus m3g, and then 2 times 1/2 is m1, 2 times 1/4 is 1/2, 2 times 1/2 is just m3, right? Totally think that that's a better way to do it. You just got to remember a Suvat trick, right? And then the cool thing is that this works no matter what. This works no matter what. I mean, even if they don't tell you the height, you don't need to know the height. The height cancels out, right? Yeah. There you go. Hope that helps. Hope that inspires you.